Let's consider now the units of heat transfer. Whether we're looking at heat transfer from one side of a window pane to the other due to conduction, from your skin to the air due to convection, or from sun to earth due to radiation, all these mechanisms come down to the same units of heat transfer. Let's consider first the heat current. The heat current carries units of joules per second or watts. This is simply saying that we have a certain amount of energy moving per unit time. And we use the variable Q to refer to this. We can also normalize this heat transfer per unit area. We refer to this as Q double prime, shown here, and we are then normalizing this watts or joules per second with meters squared. And we can schematically depict this, as shown here, as heat transfer through a given unit area. It makes sense when we look at these quantities that in addition to there being a heat current, which has units of watts, and a heat flux, which has units of watts per meter squared, that there could also be a quantity which carries units of watts per meter. We refer to this as heat current per unit length, Q prime. This is simply saying that there is a certain amount of heat transfer per unit length. And so this is a different way of normalizing the heat transfer. This particular quantity we won't be using nearly as often as we use the heat current and the heat flux.